sooner than later. Or if you wanted to take a second look at it before I grade it, we can do that. So just come see me. I'll probably start grading it fourth period. So I do. All right, this is 2-8. What page is this? Your books. Only like 7 of you have books out. 49. Page 49? Page 49, please. All right, so we've been talking about residuals. So, hey, did you get the question right on the test that a residual is a type of? Error. Very good, very good. Okay, so you have these lines of best fits. So they have these two different graphs. You have the predicted versus actual, and then you have the residual graph. Notice the residual graph is going above and below the x-axis. And that's just basically the vertical distance above or below the line of best fit. Just showing you as a flat line because it becomes easier to see patterns. Do you want patterns with residuals? No, it is. A pattern in a residual at this point is your strongest piece of evidence that it's not a good study. Okay? So, again, this is just some things that we need to talk. So we talked about a residual plot. It replaces the response variable with y residuals. Okay, so that just basically means it can be plotted on the, over, up and down on the x-axis. So the left scatter plot above shows the explanatory response or linear regression. The one on the right merely replace the y value. You have your x values the same, and you just show how high above and below the line of best fit you'd be on the x-axis. So why do we need a residual plot when we can see the amount of error each point possesses in the original scatter plot? It's a great question. Okay, if you're looking at a scatter plot, you can kind of see that you have dots above and below your line of best fit. Okay, the residual plot creates a visual display in which errors, the distance the point is from the regression line, are exaggerated. The residual plot often makes patterns emerge more clearly. Again, patterns during residual, horrible thing. And again, I know that as you go through life, there are things that you're going to doubt. People are going to present information to you. Agree? Now, someone who falls under your mindset and says something, you're not going to question it because it's in your mindset. Yes, sir.
So for that, would you have the ability to have a graph where you put it on the residual plot and it would all fall on the x-axis?
Yes.
Cool.
Yeah.
Is that a good thing?
Yes, it is, because your R value would either be exactly 1 or exactly -1. And that just means all of your data fit entirely in line. Now, if you only had 2 points plotted, 2 points defines a straight line according to geometry. So things that you might have to question on that is, oh my gosh, this fell right into a straight line. Did they really have enough data? Or one question on that too might be, let's say you had 10,000 pieces of data, 10,000 points that were all plotted, and they all fell into an exact straight line. What are you comparing? Oh, I measured the temperature in Celsius, and then I measured the temperature in Fahrenheit, and I plotted Fahrenheit on the X and Celsius on the Y. That's going to make a perfect straight line every time. Residual, 0. Your data was a perfect fit. But you could ask yourself, are you comparing two things that are different? Well, yeah, Fahrenheit versus Celsius. But you're doing temperature. So sometimes people might say, oh, look at this. It's a perfect residual plot. And we could easily on Desmos go and plot, figure out a whole bunch of points that are Fahrenheit temperatures and then convert Fahrenheit to Celsius. The 5/9 times the temperature minus 32 and 9/5 plus 32. I can't remember. It's been too long since I taught chemistry. But it's some equation that's like that. I'm impressed that I remember the 5/9 and the 9/5. But things that stick with my mind. I don't know. So to answer your question, if you had residuals that came out to 0 and you had a lot of data that was, look what they're comparing. And, kind of question that. Now, if it's two very opposite things, speed limit versus fatalities or something like that, you might be able to show that the higher you're going in a car and you get in an accident, a higher chance of a fatality taking place. I mean, if you backed into somebody's car in the parking lot doing 3 miles an hour, yeah, it sucks, but everyone's walking away. Now, you have 2 car owners that are probably a little frustrated that somebody bumped into somebody else, but you're walking away. So, there's just things that you can kind of, it's okay to question data. And it's something that, I mean, honestly, in the past couple of years, I've looked at so much more, and because I'm like an old dude, but I still act like I'm 15. I like kind of being the chump out there and questioning everything because I don't need to be told. So I heard an interesting comment this morning from the doctor who spoke in my medical class. She said, you've heard of people that are doing the Ozempic diet? Okay. So Ozempic medication was originally put in place for diabetes. So far, Ozempic, which has been on the market for probably about 2 years now, only shows positive results from the medication. So the side effects are all positive, meaning they're helpful. You go on Ozempic, it helps your cholesterol. You go on Ozempic, it helps your thyroid. You go on Ozempic, you lose weight. You go on Ozempic, these are all good things. But the hard thing to question on that is there a long-term side effect that could take place? Back in the 1950s and 60s, and even early 70s, the Surgeon General said, smoke a Winston after a big meal, it helps your digestive system. Well, the fact of the matter is nicotine itself does calm your GI system. Nicotine's not really your bad thing. Bad thing is if you're deciding to have a cigarette, which I know, a cigarette, if you don't know, was the precursor to the vape pen, just in case you didn't know, the Juul. All of the chemicals that are part of the tobacco is what is the harmful thing. The nicotine itself isn't. So I guess if you had really bad digestive problems, I bet you if you just said, we could get this person a tablet that is just nicotine, I don't think that person's going to develop lung cancer. But I don't know that for sure because we don't have the long-term effects. So, we were all subjected to COVID. I bet you, if you don't mind, raise your hand if you've had COVID in this classroom. Okay? Now, I'm not going to ask this because I don't want any debates on this, but I will tell you this. I have had more COVID vaccines in my life than I've had COVID 4 times. Okay?
But you're not dead. So
That's true. That's true.
that's what the vaccine.
That I know that they say, but so here's the kind of the scary thing with the vaccine. I know that you've all been subjected to memes or other things from your phone that you looked at. You hear about the one situation where a person went and got the vaccine and had a massive heart attack as a result of the vaccine and died. Probably heard something like that, right? Or this person has these horrible side effects where he actually grew a tail. I didn't grow a tail yet. I'm just being facetious on that one. That's not one that I've really heard. But the vaccine did come out quickly. And here's the scary thing. How a vaccine is created is it's a person that works in the medical field notices this particular type of cell interacts with this type of protein and goes to that. Now, I think all of you have heard that the vaccine is the big thing that people came out saying it's dangerous because it's an mRNA vaccine and it messes with your DNA. Do you all know that the mRNA vaccines have been around for 40 years and it's used on people with cystic fibrosis? So when people say, oh, they're using this new technology, this mRNA. No, it's been around a long time. So anytime I saw some of those faults, I would go back and look at stuff. Now, am I somebody who, and I'm just saying me as a person, I'm not going to shy away from a vaccine. And I'll tell you what, as you get older, and I bet you can ask your parents this, the shingles vaccine, I'd rather get punched in the face by Mike Tyson than get another shingles vaccine. It was like putting a Jello pudding pop in my arm. I mean, and you have to get it, and then 2 weeks later go get another one. They put it in my left arm, and basically I'm walking out of the doctor's office going like this. It broke my arm. I couldn't move it. And about 6 hours later, I was able to take it to here. About 12 hours later, I was able to take it to here. By the next morning, I was able to have full range of motion, but it hurt. And I knew I had to go get another one. That vaccine was bad, but I also know shingles sucks. My wife's had shingles 4 times. And my wife she's way tougher than me. And that wiped her out having shingles. So when they said, hey, you want the shingles vaccine? Yes, please. I've seen my wife she could beat me up in a heartbeat. Just get shingles and it just knocks her through the roof. But there's just different things that you look at. One piece of data, and that's the scary thing about the internet, especially with you guys these days, because you are the generation of instant information. So yes, it's going to be a lot easier for you going through the rest of your lives to hear of the one bad effect of something. And some of you in here might be like, well, I'm not doing that because that happened to this one person. Being this is a statistics class, let's equate one person to the entire population of the planet. You have a 1 in 8.5 billion chance. That's low, really low risk. But unfortunately, because you have the instant gratification of information, you see that one situation, and I'm not doing it because of that one situation. Every vaccine out there is going to have a side effect in a certain population. The Johnson & Johnson vaccine has some side effects that happen to a larger amount of the population. But what's the real thing to do? I don't know, it's tough. Vaccines are a tough thing to talk about because you have some people who are very much opposed to, and some people are very much for, and then the rest of the population somewhere in the middle. Yeah. What'd you find?
It's about a scholarship.
Yeah, just go up the stairs to the right. And when you go out the door, you go up the stairs. I thought you were showing me some data on vaccines. I was like, sweet. All right. So when do we look for a residual plot? Well, we're looking for the patterns. When we detect any distinct pattern in a residual plot, it usually means your prediction model has room for improvement. room for improvement is a really, really kind way of saying, there's your doubt. Okay? And it's okay to doubt stuff. It happens all the time. So, on the next page, we have this particular residual plot. I don't know, kind of looking at this, I have stuff above, I have stuff below. I should have about the same number of points above and below this residual plot. I don't know what this was plotted from. It looks like years, and it's residual. Consider the following residual plot for University of Toronto study. Okay? So there are distinct patterns into this residual plot. Before 1996, you had kind of a low week over here. Like a lot of this, here's 96, is everything's below, I guess. There's a 96 because I can't really see that real quick. 96 is right here. If I drew a vertical line right here, if I just did this, and I know on the video they can't see it, but if we just draw this. So, to the left of this line, what do you see?
Mostly below the residual.
Yeah, mostly below. Okay? So that's something that you might be like, oh, maybe there's something taking place. But also, if you take a look at 2002, I think that's 2002. What are you seeing on 2002?
Like beyond 2002?
Yeah, beyond. So this way of 2002.
Mostly below.
Mostly below.
Yes, I was trying to-
Now this whole center section here, you might see, it might look like it has a little bit of a pattern like this in there. Maybe. I mean, I'm just speculating. I'm not saying that's exactly it. But there's definitely things that are to the far left and to the far right as far as this data goes. And I don't know what they said. They said, it says, before 1996, the response variable is always lower than the regression prediction. Between 2000 and 2002, the response variable is always higher than the prediction. Okay, so they were also looking at this. Let me erase this little part. Do this. Do that. Nope. So if I erase this, I wish my eraser was better. There we go. When in doubt, erase with the hand. Okay, so if you looked at this region right in between here, look at all that data that's above it. I mean, there's just definitely specific things that might not form a pattern, but there's definitely things between the years. I mean, what you should expect to see is something similar between what's happening in between these. The stuff that's happening in between these is kind of what you would expect to see in an entire study, not between certain regions, everything's above or everything's below. Okay. This also says if we have a good feel for the way the regression model is making our errors, should there be a way to fix those errors? The quick answer is yes, but our regression model is showing distinct patterns to the way of making errors. We should search for a new model. Search for a new model means if you think that two different things that you're comparing, something's taking place, and you're getting some sort of patterns like this, doesn't mean that what you think these two things compared to is wrong. There might be some better data out there to help you with it. So like on this type of thing, the statistician would be all over it saying, you know, you're publishing this report and you have this, you have this, you have this. Like, oh, no, I just wanted to focus on this part. Ooh, now you're cutting out data. Now, it is very possible that something happened at 1996 and before, and then there might have been something that was put in place in 1996 to 2000, and then after 2000, they really changed something in the way they were collecting data for these people. I mean, there's all kinds of things that you could speculate are taking place. In a study, I gotta clear this stuff up. So down below, It says, in the study of weather phenomenon, the following residual was predicted. Okay, this is a residual plot. What do you think about this residual plot versus the one above? I mean, even if I break it up into sections, if I break this up into sections, is there anything that's sticking out to you that seems bad? Any patterns that are taking place, even if I grouped it?
Not really.
I think it's pretty good. Uh-oh. I hadn't paid attention long enough to the computer, so it went bye-bye. Okay, so there are no distinct patterns of the kinds of errors that the regression model is making. This implies that we have a model that is a good fit for the data, that we might not need to look for a different model. Okay, again, if you're going to make a choice on something in life, and I'm talking a major choice, I'm not talking about something like, should I, go get a Monster energy drink versus a different energy drink, a Red Bull or whatever. Okay, that's not the type of things that you're going to make any conclusions based off of. Okay? Oops. So, caution. Residual plots tell you that nothing about the strength of the relationship between the explanatory and the response. They only tell you whether your model fits the shape of the data well and whether you should search for a better model. Okay, so the first thing we learned about was correlation. That was the R value. If R is close to 1, it's close to our line of best fit. If R is close to -1, it's also close to our line of best fit. If it's close to 0, there's not any indication that the line of best fit is going to work out. We can't create a line or a least squares regression line that would form the data. Okay, so you have the fitted data, and then you have the residuals. Okay, the correlation R on this particular one they're claiming is 0.966. That's really good correlation. Okay, and that's from R. They get that from R squared. Indicates a strong relationship between the variables. You can see from the scatter plot that the points do in fact fit closely together. However, the residual plot on the right is showing a distinct pattern. I mean, look at this pattern it's kind of showing here. It's doing something like this. Or it's saying like, hey, over on this side, you're there. Over on this side, you're there. And then you have a whole spattering in the middle. That's something that, if you look at it, you're like, okay, this might be some stuff. So it says, however, the residual plot on the right is showing a distinct pattern. In this case, our model shows a powerful tendency to underpredict the response variable for variables of the explanatory variables. So for the X to go with the Y. Lower than 30 and higher than 50, between 30 and 50. I mean, these are all things that have over-predicting in the response variable. Okay, so is there a strong relationship between the variables according to our regression model, but we should still look for a better model? Okay, because your regression or your residuals look like this with a pattern, and this is so close, well, that means maybe go find another study that did this versus that. Did another study have the data that showed something without a pattern? Possibly. Okay, so there's strong evidence between the variable according to our regression model. We should still look for a better model. We should never be satisfied with a high correlation if our residual is telling us that we haven't captured the right fit for the data. If we look closely, we can see the original scatter plot shows a slight curved shape to it. So they're saying this data right here has a slight shape to it. It might be curving upward a little bit more, okay? But those are just things that we have to look at. But we talked about way back in other chapters how I can change the X and Y variable. I could count this slower, count this faster. It might tighten up our data a little bit. But again, the picture that you're using, you want to have that to show to your reader, hey, we got something going on. Okay, so we are guilty of trying to fit a straight line through a curve. We should put ourselves back back simply because our correlation is close to 1. Okay, that R value we said was like 0.966. Okay, That's really good for a line of best fit, but it's very possible that you could do a quadratic regression or a cubic regression, and it could find your data better. I mean, let me just show you this. I had to bring this up. Okay, I'm just going to completely make up fictitious data. Nope, wrong one. Cancel. It's 548. Let's see. Let's see if Stirrup can wing something. 1, 2. Okay, that's good. 2, 5. Oh, that's good. 3, 7. 4, 8. All right. So let me go to. Okay. I know I only have 4 data points. Agree? Oh, it's not up there. I'm sorry, you guys are looking at me like I'm crazy, which is usual. Where's my Windows K? Windows K. There we go. Windows K. That's 548. Come on, baby. Not at all. Anytime now. Okay, there we go. All right. So take a look at the data. I just made this up. It's only 4 data points. Agree? But let's just pretend I have 4,000 data points. So talk to me about what this data you're seeing as this data. Does it appear there's a curve up towards the top? Like, do you feel that this is kind of, it looks like it'd be a straight line? So I could actually do this. I can go y1 tilde mx1 plus b. And it's like, look at this. I have a residual of 0.9759. That's a really good residual. Now, if I did this, y1 tilde ax squared, oops, I need to make that an x1, ax1 squared plus bx1 plus c. Okay. So, hey, what's the red line called?
Parabola.
It's a parabola. Everyone agree with the parabola? And the black one's called the straight line, right?
Yeah.
So look at this. My straight line showed me an R value of 0.9759. Okay, and the R value, the correlation, the only time you use the R value is when you deal with a straight line. Notice when I have the parabola graph, it gives me R squared. Okay, so then I have an R squared value of 1. That says that this parabola from my data fit perfect. My friends, would you like to have $97.59 or $100?
Would you what?
Would you rather have $97.59 or $100?
$100.
$100 all day long. I like that fancy looking $100 bill. Okay? So, but here, this is a clear sign of, you know, hey, I have this great R value, so it must be, when it really comes down to this, our R squared value, in which you use for higher degrees than linear, so quadratics, cubics, things like that, we have a value at 1. Okay, that's really good. 1 is closer to 1 than 0.97, whatever, 0.9759. It's much better. So it says strong relationship between the variables according to a regression model. We should still look for a better one. Okay, we are guilty of trying to fit a straight line to a curve. So I'm showing you where a straight line and a curve, 2 different equations. I know you've dealt with parabolas at some point. I know you've dealt with straight lines at some point. Okay, that's just one clear way that doing a line of best fit, and I think it's pretty cool that Desmos allows you to figure out the quadratic equation as well. That's pretty amazing. I know the TI does as well. It says one more residual plot scenario must be discussed. A fan occurs sometimes, looks like this. Okay, so if you look at this one, the residual plot, it's all kind of bunched together here, and then it starts fanning its way out. That's another pattern. That's something that you have to look at. It says, notice the errors are relatively small for the x values below 65. That's 65-ish right here. Okay? In this case, though, the pattern does not necessarily indicate the regression model is a poor fit for the data. Rather, it indicates the model is making better predictions for some values of x and poorer predictions for other values of x. So as I go to the right, my predictions become poorer and poorer. I either over or under predict by a lot. Okay? This is an issue of fit because no curve regression model can fix this issue. Something else is going on, something more subtle, but maybe worth investigating nonetheless. So again, the residual tells you as the researcher, oh, look, this took place. Let's see what happened. Like if we're doing stuff based on time, okay, if you want to talk about, say, people living longer, do you know that they can show that people live longer now that we have clean water? But if you go back to the early 1900s, when sewage and water were using the same pipes, people were getting sick. You're like, dude, that's gross. I know. Okay? Any of you have one of those water bottles that you have the straw that's in it that'll filter out 99.999999996% of all bad stuff?
I've got a picture at home that does that.
Yeah, I mean, so basically there's water bottles you can get out there. You can go fill your water out there in the reservoir, put the cap on, the straw will filter out almost 100% of all the bad stuff. Meaning you could drink the water that comes out of that lake with no problem. Okay, yeah, you might have a better chance of getting struck by lightning 12 times and surviving than catching something bad from drinking the water through this filtration system. Okay, so there's just lots of good stuff. So I hope that I'm not going to give you an assignment because it's not fun to have an assignment over a weekend. But what we'll do is we'll go over this assignment on Monday, but I'm not expecting you to have it done.